Alright, length of longest V-shaped diagonal segment. We're given a 2D integer matrix grid, size n cross m, and values can be 0, 1 or 2. If it's a 1, that represents that's where we are going to start our start creating a V-shaped segment out of it. What is a V-shaped diagonal segment? We are given a segment that starts with 1 and follows this order from 1 to 2, 0, 2, 0, 2, 0, and so on and so forth. The segment starts along a particular diagonal direction, and it can go following the sequence. It can follow the sequence in the same diagonal direction from where it started, and it can also do one clockwise rotation and turn its direction to another diagonal, right, while maintaining the sequence all along, right? So it can go something like here, it can keep continue, or it can do this and keep continue. As long as it can, we want to find the largest this that we can form, and we always need to start from 1. So this is a straightforward DFS. We can do a DFS on this, right? What all states are we going to require? Well, we want a row, we want a column, we want a direction, right? Because if we are at a direction, we can always change the direction, but we need to know where what was the direction initially in order to go to the next direction. So we need the direction as a state. Finally, a turn, because of the fact that we can do only one clockwise rotation, and that's it. Also, we also need a number, right? Because it's going to follow the order, right? So what number it should be, what's the next number it should be. So number, or let me call it order, as a state. These are the states. So let's do it, and then we can memorize it. Let's see our answer. Let's have a m and n. I'm going to declare it outside and then initialize it inside. I'm sorry. This is m and n. We are going to go through all the cell, and if grid of ij is equal to 1, that's why we need to start the DFS. But we need to pass the direction, right? How are we going to pass the direction? What we can do is we can have a map, right? The directions are going to be 1 1. It can be, this is the diagonal directions, right? Diagonal directions. This can be 1 1, this can be minus 1 1, or let me do it in the right order. So if this is 1, if this is direction 1, this is direction 2, this is direction 3, and this is direction 4, right? This is nothing but minus 1 1, this is 1 1, this is minus 1, oh sorry, 1 minus 1, and this is minus 1 minus 1. right? So if I have a direction map, which is basically 1 pointing to this, 2 pointing to this, 3 pointing to this, and 4 pointing to this, then I can always change the direction from 1. If I have this as the current direction and I need to use the clockwise 90-degree turn, then I can change this direction to 2, by increment it to 1 and then mod it to 4, right? So if I have a 4 as a direction, then I'm no, that's the problem. Let's have it as 0. This is 1. I'm sorry for the scribble. This is 3. Alright. So I can always increment 0 to 1, 1 to 2, 2 to 3, and 3 to back to 0. So I can mod it every time I increment. So this will make my life easier. So I will have a map. This will be direction map. Let me call it direction map. This is nothing but uh, 1 pointing to a vector 1 comma minus 1 comma 1 and a comma, I'm sorry, minus 1 comma 1 and a comma. These, this will be copied 4 times. So 0 will be pointing to this, 1 will be pointing to this, 3 or 2 will be pointing to 1 comma minus 1, and 3 will be pointing to minus 1 comma minus 1. Alright, and I can call all for all the directions here. Alright, I will have an answer and maximize it. So since I am already jumping from ij to this next point using this direction, so I can increment right here at least once, and my row column, so I'll pass the grid, I'll pass the row I plus, I'll use the map and the k to increment to the next I and j, that is row and column, k of 1. The next thing I need is, in terms of state, I need a direction. So direction initially will be k, right? I need a turn, initially it will be 0. I need a order, initially it will be 2 because after 1 I need a 2, right? Straightforward. So I can return answer at this point, and let's have a solve function. This is going to return an integer. Take a grid, alright, and it's going to take a row, a column, a direction, turn, and a order, right? So uh, if it's a 2 or not, that needs to be checked here. First of all, I think what I can do is I can have a is valid function to check if things are going out of bounds. So that will be a boolean is valid. A row and a column is going to be what is needed here because I have a m and n already declared outside. check it against that. So row is greater than equal to 0 and column is greater than equal to 0. Let me write it just row first. M so if this is not valid, then let's return 0 because I can not stretch further. Length will be 0 in from this base case. If if the order is 2, then if the order is true 2, or I can just write if it's valid, because if it's not valid then it will be a 0. If its order is true 2 and grid of row column is not 2, right? Or similar case but the opposite one, if order is 0 and row column is not 0, then return 0. I cannot stretch further, right? So let me have an answer here. This will be basically length, so let me call it length. Length is going to be maximized, so I'll get a new row and new column, right? I'm basically going to get a new row and a new column. That will be basically, so let me just write things down first. So what I have is I have two choices, either to go forward or to go or change direction, right? So first choice will be basically 1 plus solve grid row plus dir map of what, of this direction and this, uh, because I need the row index value. I can have the same thing for column. The direction will stay same, the turn will stay same, the order will change, so the order will switch, right? So it doesn't matter, I can just pass 1 also, it's just the order, because I can distinguish 2 and a 1 using just 0 and a 1, right? If I have a turn, that is turn is not 0, that means I can use a turn. Actually, if turn is 0, then I can use one turn and increment it. So what's going to be the new direction? The new direction is going to be, let me get the new direction, direction plus 1 mod 3 is going to be the new direction, right? Actually this should be 0 to 3, not 1 to 4, and this will be new direction. So let me update this, update this, update this. Now turn will turn to 1 and all the other things will stay same, and that's it. We can return answer here, and let's see if this works. If this works, then we are going to minimize it. This is direction map. Okay, I don't see any problem. What is the problem? Length, sorry. Hmm. Alright, this works. Now we are going to minimize it. Lot of states, right? We have a row, a column, dir, turn, and order. Order will be of size 2, turn will be of size 2, direction will be of size 4, column, row and column is going to be of size m and n, right? So I can have something like a cache initialized to some values 4, 2, actually this should be 2, this should be 4, right? Let me initialize these values to uh, -1. Since I've declared it outside, no need to pass it. I can just check it here. If dp of row, column, direction, and turn, turn, order, if it's not equal to -1, then return and initialize it here. Let's see if this works now. Submit it. We have the time complexity as O of m cross n. So the thing that I missed was this one. This should be mod 4, not 3, because for obvious reason from 3 it will go to 0, right? So let's see if this works now. Let's submit it. In terms of time complexity, this will be O of m cross n, because these are just 4, 2, 2 small numbers, and space complexity will be again O of m cross n, right? Yeah, so that's the problem. Thanks.